So, for my project, I decided I wanted to make an arch near the memorial benches in the parking lot. I feel like an arch would be appropriate, but just like the area surrounding the benches, I would not want it to stand out too much. This means it should not be extremely tall. I want to make an arch that is kind of like a memorial to some students that we've lost over the years, and I want it to just kind of sit near the parking lot, and I want it to also have some flowers surrounding it. So here's how I made my parabola. Equation that I want to use, it is f of x is equal to negative 1 over 4 x squared plus 7, and that is in vertex form. Obviously here, right here, I have the vertex form equation written down, and then this coordinate is actually what's going to help me find my vertex in a second. But first, I do want to find the axis of symmetry, and remember that is, of course, x is equal to negative b over 2a. Yeah, this is... I don't want to use this marker right now. I'm just going to use this pen. There we go. Got my trusty pen. So negative b obviously is going to be... Hold up. This is vertex form, right? Our axis of symmetry is actually just h. But guess what? I actually figured out how to find that number already, doing incorrect math. But essentially, it's going to be 0, and I'll show you why in a second. So negative b, our b term is 0, because we don't have a b term. So it's going to be 0 over 2a. So our a term is actually right here. Remember, it's the coefficient, and it is negative 1 over 4. All right, so negative 1 over 4 times 2 is just negative 1/2. So I'm going to write that as negative 0.5. And then 0 divided by negative 0.5. You can't divide 0 into negative 0.5 pieces, so it's just going to be 0. Okay, cool. So our axis of symmetry is 0. And then look at that. Look what else I have. I have h and k, which means that this is our vertex. So we can just substitute those values back in, and we can just find our k value in our equation. Normally, you would just kind of substitute this value, whatever you got from your x is equal to negative b over 2a term, and substitute that back into your equation, and then solve and find your y value. But in this case, we can just pull it out straight from the equation. And look at that. So we have h, which is 0, and we can actually see that from this equation directly, because there is no h term, because there's no subtraction going on anywhere, and I should have a pair of parentheses around this x, but that's okay. So our vertex, and that is of course going to be the coordinate point 0, 7. So 0 is our x and 7 is our y, remind you. So yeah, it's going to reflect pretty easily, because our axis of symmetry is just the entire y-axis. How cool. All right, so now I'm going to do kind of a hard part. I'm actually going to go straight to finding the x-intercepts, and then I'm going to apply that to my arch that I'm going to be building. So if I want to find the x values, what do I have to do to this f of x? F of x is just y. And if we want to find the x values, we can just substitute that for 0. I'm actually going to write that down quickly. I'm just going to call it x values. Hopefully you understand what I'm saying when I mean that. But all right, so we're going to substitute 0 in for y. And then we're going to write our entire equation. And so if I want to, there's one way I can solve this, and that is solving by square roots. So I'm actually going to subtract 7 from both sides. And now we're going to have negative 7 is equal to negative 1 over 4 x squared. Look at me, I'm writing that incorrectly, but I don't care. And so this is the kind of tricky part. Nobody likes fractions, right? So I actually have to multiply by negative 4 in order, if I want to get rid of this. and I multiply that to both sides. And if I'm multiplying the wrong number, Mr. Cunningham, have mercy, please. All right, so then we're gonna get positive 28 is equal to x squared, right? Yeah, all right, so x squared. Where can I go from here? Well, like I said, I was gonna solve by square roots. I wonder if I can, oh my gosh, I can zoom in. That's pretty cool. All right, so I'm gonna square root both sides. So our x values are going to be equal to, and just to kind of save time, because this is close to 5 minutes already, and I'm just, like, I'm almost done, but 5 minutes is a lot. And I apologize in advance if this comes out really bad in post-production and video editing, if this comes out really terrible looking. I'll compromise, but either way. So we want to find our x values. Well, I want to add one more thing. This is positive and negative square root of 28. So, believe it or not, it is the same thing. Sorry, my cat is being adventurous. So we're going to get negative 5.29 and then positive 5.29. All right, that's pretty cool. But how is that actually going to help me? Well, let me zoom in just a bit, and I'm actually gonna draw a little thing quickly. So if let's say this line is our x-axis, right? And we want to find where it hits the x-axis, especially because it's negative. I also want to, before I continue, I do want to add one more thing. My a value right here is negative because if you're doing a parabola and you're graphing it and your a value is negative, that's going to flip the entire thing upside down. Pretty nifty. But I chose 1/4 because, believe it or not, that actually stretches out the graph if you have a fractional value. So let's say this is the x-axis, and these are our 2 points. So let's just pretend that this is the correct graph. This is not to scale, but there you have it. So this is our negative 5.29 and our positive 5.29. And what I want to do is I actually want to find the width from one end of the arch to the other. And essentially we're just kind of adding both of those. We're adding the distance from the negative, or from one of the x-intercepts to 0, or the axis of symmetry, and then doing the same thing for our other point. Now let me just draw we didn't do too good of a job, but that's okay. You get the point. This is the y, and this is the x. Cool. All right. So we want to find the width, right? Well, remember, if we're finding the distance, it's like absolute value, right? So it's just the distance away from 0, which is our axis of symmetry, which is pretty handy. That's why I didn't have an h value, because having no h value means that our x-intercept, our x value for our vertex, is just 0. So that's pretty easy enough. So we're actually going to find the distance from this point to 0 and this point to 0. But easy enough, they're the same number, so we just do 5.29. We're out of breath here. And I have my little feline friends running around. So 5.29 plus 5.29 will give us 10.58. And that's not a beautiful number, but it works out fine. So I'm actually going to switch to the marker for our final challenge, and that is the width of our parabola. And that is equal to this number, the distance between the 2 points, which is 10.58. Now let me just kind of zoom in just to, oh, well, looks like I'm not gonna be able to zoom in a bit, but yeah, there you go. Once again, there's my equation. I feel confident that I've found everything I need to do. By the way, I'll figure something out. But yeah, I have my equation right here. Once again, that is f of x is equal to negative 1/4 x squared plus 7. I found my axis of symmetry, which was just h, which is 0. And then I found my vertex, which is the coordinate pair hk. And our k is 7. And I found my x values, which actually happened to be plus or minus 5.29. And then I added those together because I wanted to find the width, and there's my width. So far, so good. So there is one thing that I completely spaced on. I did not actually show you guys exactly what the graph looks like. So here we have the graph, the parabola itself in all its glory, here graphed in Desmos for you, and you can see in the far left upper left hand corner, you can see our equation, exactly how it looks. And I want to point out the negative 5.29 and the positive 5.29. Again, those are our x-intercepts, and the distance between those points is obviously the width of the arch, and we can kind of think of the y value being 0 as kind of like the ground. So you see how like it's sitting on just sitting on the x-axis. You can kind of think of that as like the ground, and then we have our vertex 0, 7, and that's the highest point. It's gonna be about 7 feet, as we can see here.